What I'd like to look at now is using Fiddler to behave like a man in the middle, and that's what we just looked at in that prior diagram. Now, in order to do that, it's only really going to work once we can compromise the device. And in this module, device is going to mean both the PC that Fiddler's running on at the moment, and we're going to have a look at how the browser behaves in response to being man in the middle in just a moment. And it's also going to mean the mobile device. So we're going to compromise my iPhone in order to get Fiddler in the middle of the HTTPS traffic. Now I've reset my Fiddler to a pretty vanilla install. This is the way you should find yours if you haven't changed any HTTPS settings. So we're going to go through the whole thing from clean install to fully configured. It's pretty basic anyway, but I want to walk you through the steps. We're going to jump on over to Tools, go down to Fiddler Options, HTTPS, and the first thing I want to do is just capture HTTPS connects. We'll see what these guys look like in just a moment. Do note the helpful text down the bottom here though. Changes may not take effect until Fiddler is restarted. Don't forget that, because trust me, otherwise you'll be spending a lot of time wondering why your settings don't work. Okay, it's loaded back up. What I'd like to do now is show you how it behaves when an HTTPS request is made. And to do that, I'm going to drag over my website, haveibeenpwned.com. This is served securely over an HTTPS connection. Let's reload the page. Now we see a whole bunch of requests, and the host in all these requests is just tunnel2, and the URL is a domain with port 443 at the end. 443, of course, being the default port for an HTTPS connection. Now, all a tunnel is the beginning of a handshake between a client and the server before an HTTPS connection is established. The tunnel is sent via HTTP. You can see that in the protocol column. And regardless of the request, it contains nothing more than the host name we're connecting to. Fiddler puts it in the URL column, but clearly it is a host name. The consequent communication is over HTTPS. We're not seeing it here. We loaded the page, it's proxied via Fiddler, but to date, Fiddler is not capturing HTTPS traffic. Let's change that. I'm going to go to Tools, I'm going to go back to Fiddler Options, back to HTTPS, and Decrypt HTTPS traffic. Now I get a prompt, and clearly, as you can see in the prompt, this is scary text. And in fact, what Fiddler is wanting to do here is to install its own root certificate. So this is what I touched on in that diagram in the previous clip, which is simply that in order for Fiddler to re-encrypt that traffic after receiving it from the genuine host, it's going to do so with its own certificate. And unless the client trusts that root certificate, it's not going to be able to make the connection. For now though, I just want to say no, because I want to show you what happens. We'll say OK, and we'll close Fiddler. Now let's open it back up, just to make sure those settings have been applied, and we'll go back to Have I Been Pwned. Let's now reload it. And now we see a very different message. Cannot connect to the real haveibeenpwned.com. Why is this happening? Well, it becomes clear when we go up and inspect the certificate. Connection, certificate information, issued by Do Not Trust, Fiddler Root. This is Fiddler's self-signed certificate. The client, which in this case is my PC, does not trust that certificate. Why would it? Fiddler is not a trusted CA. I'm showing you this because this is the browser doing exactly what it should do. It's making sure that we have a legitimate certificate. We don't. And consequently, it's rejecting the connection. we can't see anything in Fiddler to the left of the screen to suggest that the communication has actually happened. The browser hasn't sent any of our sensitive data or put us at risk. It's done a good job. So this is what should happen when the certificate is not trusted. I'm just going to close the certificate info, go back to Fiddler, Tools, Fiddler Options, HTTPS. I'm going to decheck this and then check it again. Now what we're going to do is trust the Fiddler root certificate. We will get a big scary message which is effectively saying, hey, you are going to install a root certificate on your machine. It is going to mean that any communication that serves up a certificate signed by this provider is now going to be trusted. This is the sort of warning you do want to take very seriously, because as you're about to see, it's going to allow Fiddler to re-sign any of the HTTPS communication with its own certificate for any domain that it likes. So it's effectively doing what we entrust that CA to do, the certificate authority. Let's install it. I get a little confirmation message that's popped up on my other screen here. Are you really sure? Yes, let's do that. And again on the other screen, a confirmation that it has now been added to the machine root list. Okay, close Fiddler, open Fiddler back up, and now let's go back to Chrome. And I'm going to give this guy a reload. So now we have a very different result. The web page has loaded successfully, and it's loaded successfully with exactly the same certificate that we saw before. Here it is, do not trust Fiddler root. But now because we have compromised the machine, that is, we've compromised my PC, when Chrome tries to load this website and it receives Fiddler's root certificate, it completes the certificate chain, the trust is established, and Chrome successfully loads the website. Now as such, we can also see the website here just as another normal request. Inspectors, we'll decode, and here's the web view. It's just a normal HTML web page. We're viewing this HTTPS connection just the same way as we've been viewing HTTP connections throughout this course. So that is a very simple overview of how to compromise your PC. Let's now move on, and I want to show you what happens on my iPhone when we proxy HTTPS traffic back through Fiddler now that it's been configured to try and decrypt that HTTPS connection.